Welcome to the second lesson in Session 5, Multiplying Polynomials. We're going to start by multiplying a monomial by a polynomial. So that's multiplying a single term by an undefined number of terms. When multiplying polynomials, we require extensive use of the distributive property in combining of like terms. So here are two examples. In the first one we have 3x. It's being multiplied by 4x to the second minus 6x. So we have to use the distributive property here and make sure that the 3x gets multiplied by every single term inside the parentheses. 3x is going to get multiplied by 4x, and 3x is going to get multiplied by negative 6x. When that occurs, we end up with 12x to the third minus 18x to the second. Now those two terms cannot be combined any further because they're not like terms, so we accept 12x cubed minus 18x squared as our answer. In the next example, we have two separate steps of distributive property that we have to use. 5x is getting multiplied by 3x squared plus x, and negative x is being multiplied by x squared minus 7x. We start by distributing the 5x. 5x gets multiplied by 3x to the second, and 5x gets multiplied by x. That product gives us 15x to the third plus 5x. Next we move on to the negative x. Negative x gets multiplied by x to the second, and negative x gets multiplied by negative 7x. That produces negative x to the third plus 7x to the second. Now we look to combine like terms. We've got two cubic terms and 15x to the third minus x to the third. They combine to give us 14x to the third, and 5x squared plus 7x squared give us 12x squared. As we move on, we're going to multiply binomials. So in this case, we're going to multiply a binomial times a binomial. Now to multiply binomials, we have to distribute each term in the first binomial into each term in the second binomial. We finish the problem by combining like terms. The acronym FOIL is a helpful device to help students when learning how to multiply binomials. It stands for first, outer, inner, last. Multiply the first terms, then you multiply the outside terms, then you multiply the inside terms, then you multiply the last terms. For example, we have x plus 3 is being multiplied by x minus 4. So we start with the first term in the first binomial, and that's x. X gets multiplied by each term in the second binomial. So we start by multiplying x times x, and then we multiply x times negative 4. That gives us x to the second minus 4x. Now we move on to the second term in the first binomial, and that's 3. 3 gets multiplied by each term in the second binomial. So 3 gets multiplied by x, and 3 gets multiplied by negative 4. That gives us 3x minus 12. So you see FOIL comes from, the first step is multiplying the very first terms in each binomial, x times x. The O stands for the outside terms, x times negative 4 gives us negative 4x. The I stands for the inside terms, which is 3x, or 3 and x, and that gives us positive 3x. And the 3 and the negative 4 give us negative 12. Those are the last terms. Now we finish by combining like terms. The two inside terms are like terms, so we combine them to get x squared minus x minus 12. Now in the second example, we have 2x minus 1, and it's being multiplied by 3x minus 4. So the first two terms get multiplied, 2x times 3x, and then the outside terms get multiplied, 2x times negative 4. So after distributing the 2x into the second binomial, we get 6x to the second minus 8x. Moving to the second term, we get negative 1 being multiplied by 3x, and negative 1 being multiplied by negative 4. That gives us negative 3x plus 4. Again, we combine the inside terms. The negative 8x and the negative 3x are like terms, so our answer is going to be 6x to the second minus 11x plus 4. Next, we're going to multiply a binomial times a trinomial. So to multiply a binomial times a trinomial, we need to distribute each term from the binomial into each term for the trinomial and then combine like terms. In the example we're going to provide, we have x minus 2 representing the binomial, and we're going to multiply that by x squared plus 3x plus 4. So we start with the first term in the binomial, x, and we're going to distribute to each term in the trinomial. So x gets multiplied by x to the second, x gets multiplied by 3x, and x gets multiplied by 4. That produces x to the third plus 3x minus 4x. Once we finish with the x, we move on to negative 2. Negative 2 now has to get distributed to each term in the trinomial. So negative 2 gets multiplied by x to the second, negative 2 gets multiplied by 3x, and negative 2 gets multiplied by 4. That gives us negative 2x to the second minus 6x minus 8. Now notice how I wrote these two products on top of each other rather than horizontally. Writing them vertically, as we have here, makes it much easier to identify the like terms and combine them. So you can see x to the third doesn't have anything to combine with. 3x minus 2x, 3x to the second minus 2x to the second gives us 1x to the second. 4x minus 6x gives us negative 2x, and the negative 8 doesn't have anything to combine with. So we accept x to the third plus x to the second minus 2x minus 8 as our answer. Now as we wrap up this lesson, there's a couple of special cases that we need to identify. The first one is the square of a binomial. The square of a binomial always produces a trinomial, and it's helpful to learn the following patterns. Here the square of a binomial is a plus b, and that whole quantity is being raised to the second power. So we square the first term, we double the product, 2 times a times b, and then we square the last term. So when you have a square of a binomial, we take the square of the first term, we double the product of the two terms, and we square the last term. A squared plus 2ab plus b squared. When it's a minus b raised to the second power, the only difference occurs in the linear term. That middle term will be negative instead of positive. The first term is still positive, and the last term is still positive, but that middle term, the negative 2ab, will be negative rather than positive. So we square the first term, double the product of the two terms, square the last term. Here we have a couple of examples, the quantity of x plus 4 being raised to the second power, and the quantity of 2x minus 3y being raised to the second power. So for this example, we'll show you by expansion. So x plus 4, when it's being raised to the second power, that means we're multiplying it by itself. So that's x plus 4 times x plus 4. So we distribute, that gives us x squared plus 8x plus 16. So we square the first term, we double the product, 2 times x times 4 gives us 8x, and we square the last term, 16. Next we have 2x minus 3y quantity squared. Squaring the first term gives us 4x to the second. 2x times negative 3y is negative 6xy, and if we double that, we get negative 12xy. And negative 3y to the second power is positive 9y squared. Our other special case is the difference of two squares. The difference of squares pattern is an extremely important concept for an algebra learner to recognize. The difference of squares looks like a plus b times a minus b. It's very similar to that of a conjugate. And when you multiply a plus b times a minus b, the result is a squared minus b squared. And it's called the difference of squares because the result, perfect square minus another perfect square. So that's the difference of two perfect squares. So for our example, we have x plus 4 times x minus 4. So when we distribute that, we're going to take the square of the first terms, which is x squared, and multiply the last terms together, which is 4 and negative 4, which gives us negative 16. So that wraps up our lesson for section 5.2. In order to earn credit for the lesson, you need to successfully complete the quiz. Please email us if you have any questions. Good luck.